So picture this. You've got a massive, multi-million-dollar solar plant, and one day, it just starts underperforming. No big alarms, nothing obvious. It's a high-stakes mystery that can cost a fortune. Today, we're going to crack the code on how to solve it. Right, let's just dive straight into a scenario that, believe me, keeps plant operators up at night. You're responsible for this huge solar farm, a massive asset, and the data says it's just not putting out the power it's supposed to. No smoking gun, no obvious damage, so where on earth do you even start looking? And make no mistake, the stakes are incredibly high. A performance gap that seems small, like, say, just 4.6%, well, that can snowball into a nearly 6% loss in your annual yield. For a big plant, we're talking about very real, very significant financial losses. Every single percentage point really, really matters. To solve this mystery, we need to get to know our number one investigative tool. And it's probably not what you think. It's not a wrench. It's not a voltmeter, at least not at first. It's the plant's digital brain, the SCADA system. Now, SCADA stands for Supervisory Control and Data Acquisition. The best way to think of it is as the central nervous system for the entire solar farm. It's the one place that sees everything, gathers all the data, processes it, and shows you what's happening across thousands of components, all in real time. So, how does it all work? Well, you can break it down into 4 key parts. First, you have your field devices, all the sensors, inverters, and meters out there in the sun, collecting raw data. Then you've got the communication network, which acts like the data highway, getting that information back to base. That's where the SCADA servers, the brain, take over, processing and storing everything. And finally, you have the HMI, the human-machine interface. That's the screen you're looking at, the dashboards and charts where it all comes together. Now, this is a really crucial point. Why is SCADA so different from, say, just logging into an inverter's own monitoring website? Well, that local monitoring is like looking at a single piece of a giant jigsaw puzzle. It's useful, but it only shows you one tiny part. A SCADA system, on the other hand, gives you the picture on the box LED. It integrates everything, the inverters, the weather station, the grid connection, into one unified view. Okay, so now we know our tool. Let's put on our detective hats and take a look at the lineup of usual suspects. When a plant starts to underperform, where does the evidence usually point first? And you might be surprised by this, but here's the number one culprit. It's almost never the super advanced solar panels or the complex inverters. Nope. The most common reason for a service call is much, much simpler. It's a network outage. If the data can't get from the field back to the server, you are completely flying blind. And of course, it doesn't just stop at total network failures. The list of suspects is actually pretty long. You could have a single device just go offline. The network might be unreliable. You could have weird time sync problems where data from different places just doesn't line up. Or it could be a simple human error, like incorrect data scaling, which basically means the numbers you're looking at are completely wrong. And you can't forget the basics. A sensor could just be busted or out of calibration. So, with all these things that could possibly go wrong, how do you even begin to investigate without just running around in circles? Well, that's where the playbook comes in. We need a clear, systematic process. Here is the golden rule of modern troubleshooting, and it's a big one. Start with the data. Before you even think about grabbing your keys and driving out to the site, you dig into the trends in the SCADA system. Are there gaps, flat lines where you expect to see curves? Is one whole section of the plant behaving differently? The first clues are always, always on the screen. This brings us to a really smart, multi-level approach. Level 1 is just you and the SCADA data. At level 2, then you go on site for a visual check, look for the obvious stuff. For level 3, you get targeted. You use the data from level 1 to pinpoint the worst performing areas, and then you break out the electrical testing gear. And finally, level 4, you bring in a thermal camera to look for heat signatures the human eye just can't see. See, by following this playbook, you're not just guessing anymore. You're systematically collecting different kinds of evidence, digital, visual, electrical, and thermal, to build a rock-solid case that leads you right to the real problem. And this is where it all comes together. Think of this table as the detective's conclusion board. For example, look at that first row. SCADA shows a 5% power drop. Visually, everything's fine. Electrically, it's fine. Thermally, it's fine. What's the most likely culprit? Probably just dirty panels. But now compare that to the second row. Same 5% power drop, but this time the thermal scan finds one really hot module. Bingo, that's an internal cell fault. Every different combination of clues points to a different root cause. And that right there is the key takeaway. It is the combination of all these different data sources that lets you go from a vague, something's wrong, to a definitive diagnosis. It means you're applying the right fix to the right problem, which saves a ton of time and money. Now, solving the crime is great, but you know what's even better? Preventing it from happening again. And that all comes down to good old-fashioned best practices. You got to back up your system configurations regularly, keep your software updated with a solid patch management schedule, log every single change that's made to the system, and, like we said before, use a dedicated, reliable network whenever you possibly can. So this leaves us with one final thought to chew on. We've just walked through a very human-led, systematic process. But as these solar plants get even bigger, even more complex, how is something like artificial intelligence going to change the game? Could an AI become the new lead detective, spotting tiny patterns in the data that a human might miss and flagging a problem before it even happens? The future of troubleshooting is definitely on its way.